the reason why I came to Germany is I went to a Swiss school. So I started having some German already in Brazil, and I went to a Swiss school in Brazil. And so going to a Swiss school in Brazil is definitely a lot of privilege. And I knew I wanted to study outside of Brazil. And then you start talking, okay, where can I afford? So US was out of the list because it's quite expensive. Then Swiss school, you obviously think about Switzerland, but as a foreigner, ETH is actually expensive, and I did not have the grades for ETH. And then when you do the price quality measurement as a high school student, the TUM actually goes quite up. I mean, it's a very good university, very cheap. So indeed, I decided more for TUM than for Germany. Now I had the situation where I was like, okay, I hate the course that I'm studying. I can't study anything in the mechanical engineering faculty. I could go back to Brazil, but that's not really what I wanted because I actually like my life here. And I guess the only lucky thing in this whole story is that I applied as soon as applications opened, which means that by the time that I got the answer and the rejections, I had 3 days before applications closed. And that's where computer science came in. Computer science was outside of the mechanical engineering faculty. I had a friend at this point that already studied computer science, and he told me about it. And I mean, I did like computers, and I had coded in HTML. And that's when I applied to computer science. So like third choice.
Okay.
That's how I landed there. Did pass, did get in, thankfully. And I'll tell you one thing, it was one of the, I say that there are like two amazing decisions that I did in my life, probably three, probably you said a third one by now. The first one was moving to Germany. The second one was choosing computer science. So first step is decide your language. Second step is Google programming language tutorial. And the second you do that, we'll probably get like millions of search results because, and that's where it actually starts to get hard. Because that's a step where it starts to get a bit overwhelming, right?
Yes.
And unfortunately, this is only going out later this week because actually tomorrow at exactly this time, the Munich Geekettes are hosting an event called Embracing Coding, where we're going to talk exactly about this topic. So I don't want to spoil too much of our event tomorrow. But recently, I just had a talk with the people from Code Jam, for example, Codam, actually, Codam. And they are a coding school in Amsterdam, and I talked to the people from the Amsterdam chapter, but they actually have things all over the world. And basically, they will teach you everything you need to get a job. It's not just to code, it's to get a job in programming and in software engineering without you ever attending university, and everyone can do it. Any woman, girl, whatever age watching this anytime in the future, if you want to learn how to code and want to do something to go in that direction, and you're stuck in whichever point it is and you're about to give up, LinkedIn me. If you LinkedIn me, you can find me. Write me in LinkedIn. Write me. I'd much rather you write me than you give up, okay? At any point in the future. I think that's like the key word of what you just said is, and you can only know what the bottleneck is if you already have something running and working in the first place.
Yes.
So it doesn't make sense to start by the optimization. I would always start by the implementation, then run it, and maybe it's good enough. Maybe I don't even need the optimization, but maybe it is taking too long at some step. It does happen. So MUI, for example, we have the problem that our server is loading it takes forever to load, right? So we did identify that as a bottleneck, and we're now working on it. But you first need to get something to work, then you can identify the bottleneck, and then you can optimize it. Because if you don't do it like that, if you start by the optimization, you run the risk of spending so much time, and you can really like spend infinite amount of times in these things, optimizing something that is completely useless, that will bring nothing. I can highly recommend the documentary to everyone. First thought about that is definitely scary. It definitely is responsible for a few of the problems that we're seeing in the world right now. It is definitely responsible for this huge polarization that we're seeing in the world right now. I remember like the last Brazilian election, right? And even the two last American elections, and Brexit, and the last Brazilian election, and so many of these things. It's just like this huge, it's one group against the other group, and there's zero middle ground. And I think it's just discussing the way that these things have evolved, because like if you're in this one group, you're only getting notifications and news and articles and comments about this one group, so you will reinforce all of the opinions in this one group, and you just stay there, and you will never move 1 millimeter in the other direction to get a different opinion on it. I think that is so much connected to like the core of computer science, because computer science at its absolute core is just logic. And logic seems so simple, right? Logic, the beauty of logic is that it sounds so simple, but in reality it is not.
Yeah.
Logic can be very, very, very complicated. And the beauty of logic is that you can usually take the one step at a time approach to it to get to the complicated part, and you can usually start at the very simple, which is why I say first get something to work. And just being able to organize the hard part, going back to what we're talking about programming, right? The hard part about programming is not the computer part, it's the logic part. It's being able to, it's learning how to structure your thoughts into this one step at a time approach, breaking it down into the simplest steps in order to get those steps as simple as possible, and then getting them to work. That's the hard part about programming. I'd actually already been working in transportation even before the Hyperloop. So during my bachelor, for example, I did my bachelor thesis in Singapore at a traffic simulation research group. It was a research group that was developing a traffic simulation, and I helped with the development of a few of the components. So my whole thing with transportation and mobility is actually already before the Hyperloop. And the whole story of the Hyperloop, right? The Hyperloop concept is an amazing concept. I was towards the end of my master's, at that point where you should be searching for a thesis and should be thinking about how to finish it. And as any good student, instead of searching for a thesis, I was on Facebook. Just dumb scrolling through Facebook, literally dumb scrolling through Facebook, when I see this post from Wait But Why, which is an amazing page that I can only recommend, from Tim Urban. Wait But Why. It's a blog. It's a blog that explains very complex scientific topics in a very easy stick man figure anyone can understand language. It's really awesome. And I already knew them from before, and therefore I had followed them on Facebook, and therefore I got this post on my Facebook newsfeed that Wait But Why was talking about the Hyperloop, because he was doing a series or starting a series on Elon Musk, and therefore he was one of the first people who get notified when the competition was announced, and he wrote a post about it. It was for Tim Urban on Wait But Why usually writes like humongous posts, and this one is actually quite short and you could read it in like 15 minutes. Awesome. It wasn't the first time that I had heard about the Hyperloop, because I had heard about it in 2013 when Elon published the alpha study. But it was the first time that I looked into it in detail. And the whole thing was SpaceX is announcing a student competition for university students to build a prototype, to design and build a prototype. And for someone who was searching for a master thesis, I was like, that's a cool master thesis. So this is really the story of how me dumb scrolling through Facebook found, interesting master thesis. And literally the neighbor of the aerodynamics chair is VAR. VAR is actually at the space flight and rocketry. So back then it was a chair, now it's a faculty. And they told me to talk to VAR for two reasons. A, VAR would find the SpaceX part of it cool, because maybe VAR doesn't have much to do about Hyperloops, but they do have a lot to do with SpaceX, because they do build rockets. Maybe not SpaceX-sized rockets, but small rockets that do get launched. They did find interesting the SpaceX part of it. And even more important than that, VAR had experience in building stuff, in building the actual hardware and the actual practical side of building prototypes. That's exactly what they do. That's exactly what they did. And I did that, and I did go to VAR, and at VAR I found the first, so the first 7 people from the team was me and my friend, and 5 people that I basically stole from other projects at VAR. Here's the actual story behind the win that I'm not sure if I've already told it like this. Okay. So Indeed, we did not win the category we wanted to win. Here's something that most people don't know. In this first competition, there were actually two categories, design and fastest pod. And we always wanted to go for the design category. We built and optimized, going back to the optimization, we optimized for the design category. That's why we had a huge compressor on the front. Our compressor made 0 sense on the speed criteria. It did make sense in the scalability and design criteria, but we still had our amazing compressor in the front. We optimized for the design category, not for the speed one, functionality and technical design. That's what we wanted to win. And then our main competitors, so basically we had like two main competitors, the Delft team and the MIT team. The Delft team, on the other hand, they had optimized for the speed category, and they ended up taking the design category. So we completely switched. We wanted the design and got speed, and Delft wanted speed and got design. And the reason for, and there's a very funny story as to why. Stopped, like, I think their pod only rode a very few meters after the pusher and stopped in the middle of the tube. We won fastest pod because we removed the magnets, and therefore we were the only team that made it to the end of the tube. It's not because we were fast, it's because we were the only ones that made it to the end. And then what I also realized is if we want to solve transportation, if we want to solve mobility, there is so much that we can already do today with the regulations and frameworks that we have, technology that we have today, that would have as high an impact as the Hyperloop. And it's practicable today inside of cities, which is why I started my PhD in the direction of integrating different modes of transportation, and the way that PhDs work between what you start and what you deliver, there's like this huge gap. So that's what I wanted to do when I started my PhD, was integrating different modes of transportation. That is not what I ended up doing in my PhD, but it is to some extent what I want to do in my startup. So for me, the way to solve transportation definitely is through multimodal transportation, definitely yes. I really think that the only way to solve is integrating the different modes of transportation, one with each other, much better. Basically, what MOVI does is that it gets the whole route calculation process that many other people do, and we add 2 layers to it. A, the personalization of the constraints that I talked about, and the integrating different modes of transportation that I talked about. And B, and the thing of it is, when you do that, the first thing, an interesting thing that happens is that the number of route possibility really gets really big, because if you're using more than one mode of transportation, then you have so many routes to choose from. So what we do in MOVI is that we sort these routes by sustainability. And then we bring in the whole sustainability aspect to it. Because solving transportation, solving traffic isn't just about reducing the time stuck in traffic, it is also about doing something for the environment. And the sustainability aspect for me is very important. There are 17 goals that the United Nations came up with in 2015. And they are the 17 goals that if humanity were to focus in only those 17 goals, and the UN wanted to solve those 17 things by 2030, then we would have basically solved humanity and solved all of the world's problems. It's a list of the 17 things the world should really focus on. And in my opinion, anyone who is not working with one of the 17 SDGs can do something better for society. So the SDGs are Sustainable Development Goals. They do include things as zero hunger. And of course, it's really hard to achieve zero hunger. But you know what? One step at a time. You need to start somewhere, one step.